What is the radius of a circle? Radius is a segment whose endpoints are the center of a circle and a point on the circle. That is, we know that a line segment has two endpoints. So one endpoint is the center of the circle and the other endpoint is on the circle. That's what it is. Now here I have A as the center of the circle and there is a point B on the circle. So when I join those 2 points A and B, what we get is the radius of the circle. So this is the radius of the circle. So in this circle with center A and B is a point on the circle and the radius is AB, and there he is saying all radii of the same circle are congruent. That is, when you have more than one radius, then the plural form of radius is radii. Now from A you go all the way up to B, that's one radius. Now let us take one more point. This is other radius, this is the third one, the fourth. All these measures are the same. That's why they say that they are congruent. Now also let me show you how we denote a circle with the center A is denoted like this. If I draw a small circle and here if I put A, this is called as a circle whose center is A, and AB is a line segment and it is the radius. The radius is AB. AB is the radius, right? And I can just write this is a segment, so you can just write it down as a line segment AB with that symbolic notation. And this is a circle here. This is telling me that this is a circle with center whose center is A and AB is the radius. Okay, now the next word in this circles we have is a chord. What is a chord? A chord is a segment whose endpoints are the 2 points on the circle. That is, just take any 2 points on a circle. Here I have a point, let me call this as a point P and another point Q. Q is the second point. Now join those 2 points P and Q. This segment is called as a chord. This is the chord. A chord is a segment whose endpoints are lying on the circle. Both the endpoints of the chord are on the circle. What is the difference from the radius? We had a radius here. This is the radius because the one endpoint of the radius is the center of the circle and the other endpoint is on the circle, and that was your radius. Okay, but this is the chord. A chord has both the endpoints on the circle. Okay, now how many chords do you think you can draw on a given circle? We can draw infinite number of chords. Like join these 2 points, you get one chord. Let me join that point over here, you'll get another chord. Let me join here. This is a chord connecting 2 points of the circle. This is another chord connecting 2 points on the circle. Likewise, infinite number of chords can be drawn on a given circle. What is the condition? Just remember, both the endpoints of the segment have to lie on the same circle. So now from chord we go to a next word, that is a diameter. What is the diameter of a circle? A diameter of a circle is nothing but a chord. It is a chord which passes through the center of the circle. Here we defined what is a chord, connecting any 2 points of the circle. Now that particular chord which passes through the center. Can go this way or that way, horizontally, vertically, or slant, whatever way. These are all the chords, but they are the special chords. That's why we call them as a diameter. So let me get one for you here, this figure also. This is a diameter. Now we have one more diameter here. Let me, if I call this as X, Y is one diameter. You can have PQ, another one. So any number of diameters you can draw. What is the only condition is it has to be a chord. That is, the two endpoints are lying on the circle, like X is one endpoint, Y is other endpoint. Those two endpoints are lying on the circle, and it is also passing through the center of the circle. Here P is a point on the circle, Q is another point on the circle. That segment is joining the 2 points P and Q and passing through the center. So that's why these are all called as chords. And also this diameter is the biggest chord in a circle. The length of this diameter is the maximum length of a chord that you can get. Now here, let us say I have one chord here. This is a chord. This is smaller. One more I got here. This is also smaller. But once the chord changes to the diameter, that length is the maximum. Okay. So we say that the diameter is the longest chord of a circle. Now next we have a secant. What is a secant? It is a line that intersects the circle in 2 points. Okay, first let us see. Here we have a circle with center A. Now a line. What is the relation between this line and the circle? At first now I see that there is no connection between those two. The line is by itself and the circle is by itself. Okay, there is no any relationship between them. But as you move towards the circle, at one particular point the circle touches the line, or the line touches the circle, and also at this particular instant it is intersecting the circle at 2 points. And namely, I can call this as one point, if you call it as a point P, and this is Q. Okay, so this line is intersecting the circle at 2 points P and Q. Therefore, it is called as a secant. Secant is nothing but a line. It can be a straight line or a long segment, that's fine. Only condition is it is intersecting at 2 different points. PQ. Here PQ is a straight line intersecting at 2 different points on the given circle. Namely this thing. Let me draw one more. Here this is another one. This is a secant, that is secant, because the points of intersections are different. Here these are the 2 points, right? This is one secant, another secant. Alright, so that is a secant. Now the next one is a tangent. That's very easy. A line that intersects the circles in exactly 1 point. So draw a line. Here this is no connection, but when you move it towards the circle, you observe that it is touching at 1 point, right? When it touches at one particular point, let me call that point as a B over. So let me take C. C is the point of contact between this line and the circle. So we can call this particular line as a tangent. Alright. If we name this line as, let us say this is the line L. L is a tangent to the given circle. Now there is an important relationship between the radius and the tangent of a circle. It is like this. The angle between the radius and the tangent is always 90 degrees. That is, the radius is perpendicular to the tangent. This angle between the radius and the tangent is always 90 degrees. And the 90 degrees is found at this point of contact. Point of contact. Okay. We have here, this is the point of contact. Alright, C is the point of contact and the angle here is 90 degrees. So therefore, what I can say is this radius AC is perpendicular to the line L. This is the symbol for perpendicular to. So radius is always perpendicular to the tangent. Please remember that. Okay, now next word we have here, number of words. Let us look at one word at a time. We have an arc, minor arc, major arc, and semicircle. So an arc is a portion of a circle's circumference is called an arc. That is, when you take a part of a circle, see, this whole thing is a circle. It is a complete circumference. So from that circumference, just a part, if you take a part of it, let us say I am taking this part. So that is an arc. Now let me take 2 points. This is the point A on the circle and another point B on the circle. Now the 2 endpoints and the points on the circle between those 2 endpoints define a circle. That is, from A, including A, if I take out this, all the points up to point B, this makes one arc. And the symbol for this arc is this little arc. Now I'll say AB. AB is the arc here. A small arc symbol. Right? That is the arc. Now, minor arc is that if a circle is divided into 2 unequal arcs, that is the sizes. You see here, this is a small arc I have and the other red part, so much is left over in the circumference of the circle. So the 2 parts are unequal parts. Now the shorter arc is called as the minor arc and the longer arc is called as the major arc. Okay. So symbolically now this AB is the minor arc. Now how do you denote this major arc? To denote this major arc, it is always preferable to have one more point lying on the major arc. So here I have ACB. This whole surface, this part is called as the major arc. So symbol is ACB and with that arc symbol, that gives me a major arc. Right? So that's what you have here. If we call the portion of the circle between and including the points A and B is arc AB, denoted by arc AB. That's what they are saying here. And we call the remaining portion of the circle as arc ACB. This is that arc ACB. And most of the cases, major arcs are denoted by 3 letters. We use 3 letters, and sometimes in some scenario even the minor arc will denote by 3 letters. We can see it as an example in the next slide. Now the next word here is semicircle. What is a semicircle? If the circle is divided into 2 equal arcs, then each arc is called as a semicircle. Now what is the best thing that can divide a circle into 2 parts? It is the diameter. So this diameter divides the circle into 2 parts. Right? Now this is one semicircle I got from the diameter, and this is one semicircle Okay, let me do it again. This, starting from this point all the way there, this is one semicircle, and this is the second semicircle. Let me show you how to write it down here. Suppose if I call ABC is over, this is D is one endpoint of the diameter, E is the other endpoint. So this semicircle I can denote it as DAE. The same thing, DAE, you can also denote it as DBE, taking three letters, the first point and the last point of that semicircle. D is the first, E is the other endpoint. In between, just note down one of these points, either A or B. It denotes the same semicircle, and the other semicircle is DCE. Okay, so in this you saw an arc which is a part of a circle, and among the arcs one is a minor, next is a major, and a semicircle. Very simple, right? Okay, now we have a figure here. In the figure, so many points are there. The center is O. O is the center. A is a point on the circle. You have a point B, and F, D, E, they're all there. And you're asked to label this, right? What is the radius? Write down symbolically what is the radius, where is the diameter, chord, secant, tangent, arc, minor arc, major arc, semicircle, etc. Okay, let us see what is the radius here. We see that O is the center, and any point on the circle, I can say OB is the radius. Not only this OB is the radius, if you want you can also write down OA as the radius, or O to D is the radius, right? So I'll write here OB is the best representation of the radius, or if you want to say, I can even write down from O to A, and O to D. O is the center, and D is a point on the circle, like this, O to D. That is also radius. Now, next thing is the diameter. The diameter is the longest chord. That is, the two endpoints of the diameter have to be there on the circle, and also it has to pass through the center. So that condition is fulfilled by AD here, right? A to D. A is a point on the circle, D is a point on the circle, AD is a line segment, and it is passing through the center. Here even EF, sometimes we get confused with the chord or secant with the diameter. Secant is something which is extended on either side, and it is not passing through the center in this case. Most important thing is the diameter has to pass through the center. So here we have only AD as the diameter, right? A to D is the diameter. Next, we are looking for a chord. Where is the chord here? If you want, you can write down AD is again a chord. It fulfills the condition for a chord, but precisely this line segment EF. Only the line segment we take, not the whole straight line. That's why I am writing here EF, and with the symbol of this line segment, telling me that E and F are the endpoints of this chord. So you are taking only this piece of the whole line. That's why it is the chord. Then comes a secant. You know that a secant is a line which is intersecting the circle at two different points. So EF is again a secant. From chord you are calling it as a secant just because on the top of it you are writing down the symbol of a straight line. So EF in this case is a straight line. Straight line, cutting the circle at 2 points E and F. Whereas in the chord, it is a segment with endpoints at E and F. Please try to distinguish between the segment and a straight line. Okay, very good. Now next thing is a tangent. You know that a tangent is a line which touches the circle at one point. The tangent is touching the circle at one point and it is perpendicular to the radius. So I see here BC is the tangent. BC, and in this case it is a straight line I have. So BC. Then the arc, you have so many arcs here. A to B is one arc, B to D is the second arc, even ED or EF or FA. Anything is fine. I'll just write down AB. AB is one arc. Now then you are looking for a minor arc. Okay, let me show the arc here. This is the arc I got. Then the tangent, I forgot here. Let me go ahead and finish off this. This is a tangent, and then the secant is this. The chord is EF. Okay. Now I got the arc, and the minor arc is a smaller one. See, this is the diameter, you know, AD is the diameter, so this is half of the circle. Anything below that is a minor arc. I can call AB as one minor arc, or B to D is other one. Let me take BD. Or let me also show you how to use 3 letters in a minor arc. So in this case, I can take DEF. This arc, even though you are using 3 letters, D, E and F, still it is a minor arc. This is smaller than the whole of this semicircle. So minor arc I got. Now the major arc is the one which is more than half of the circle. So we know that AD is the diameter, so this whole thing is half of the circle. Now anything above that is a major arc. Now what is this point here? That is a B, right? Starting from this point D, if I start from D here and go all the way up to A, that is half, and little more than that. So it is like D, F, B. D, F, B is a major arc. The same DFB, you can also call it as a DEB or DAB. Same thing it is, like we discussed earlier, right? That's a minor arc. And lastly, you are looking for a semicircle. Semicircle is this. Let me use a different color. From D, this one, D to A. That is your semicircle, right? D to A. D to A or A to D, it is the same thing. But if I just say D to A, it will confuse us. So instead of writing D to A, what is the best way? I'll write as DEA. DEA is a semicircle. The same DEA, we can also take it as DFA. DFA is the same semicircle. And this side, if you want to write it down, I can say DBA, right? That is other one, all right? So these are the different words that are used in circle, and please try to identify each one of them and have a clear idea of those things. Okay, thank you. Thanks for watching.